love this class.
Let's begin.
Don't do it.
So we're starting today with a warm-up, and all I asked you to do is draw any triangle and label the sides so that one of the sides end up resulting in the square root of 1 minus x squared. So I'm going to draw a triangle. I'm just going to call an angle theta. So who's got an answer? Tell me what anyone put for the hypotenuse. Yeah, Colin.
1.
1. And what does one of the other sides have to be? X, right? Does it matter which side?
No.
So then the third side by Pythagorean theorem is 1 minus x squared.
On camera phone call.
Is that like who's calling?
If somebody gets called down, it's going to be on video. Duty call.
I haven't broken any rules today.
Can I just stop touching slots? Sure, one
But
moment.
I am responsible.
Phone's for you.
Liam, what did you do this time?
Always give me on camera.
Alright, very good. So this is going to lead us into what we're doing today. So today we're learning a method called Trig Substitution. And at the end of this lesson, you will be able to evaluate integrals
Oh, Liam, what did you do this time?
involving, it says 3 cases of radical functions, and it is 3 cases of radical functions, but in a lot of different contexts. It's a great method for integrating radical functions in pretty much any context. So, and we're going to use trig identities in order to do it.
Oh yeah.
Are you super? Okay, good. Now, I'm going to skip this. These are the 3 cases that I taught students in my prior periods of the day, and we might come back to this, we might not. I'm going to let it sit on the camera for 1 second. There you go. If you want to use the old method, there it is. All right. So, but we're going to do it slightly differently. So, you use this method anytime you have an integral with a square root of something squared plus or minus something squared. All right? So, we're talking about constant and an x value, or if you have like a trinomial and you complete the square to make it in terms of a constant and like a u value, right? Something like that. So something squared plus or minus something squared. The first thing that we do is we draw a triangle. And pick an angle, call it theta. That's my theta. You want to look at your root and label the sides of the triangle so that one of the sides ends up being that root. It doesn't matter what else is in the integral. Just look at the root. So tell me something, what does the hypotenuse have to be?
3.
Is it 3 or is it 9?
3.
It's 3. It's always the square root of the number. Good. Now, just so you know, if it was x squared minus 9, then the hypotenuse would be x. It's whatever is the first term in the subtraction, right? Something like that. All right. Then, what does either side need to be? X, right? Which side do you have least? Bottom. You got it. Okay. So the square is the square root of 9 minus x squared. All right. What we're going to do now is we are going to write what the square root of 9 minus x squared equals in terms of the triangle so that we can replace it in our problem. So we have root 9 minus x squared. Well, let's see. I know that the sine of theta equals root 9 minus x squared over 3, right? So that means root 9 minus x squared must just equal 3 sine theta. So I can, in my integral, replace the root 9 minus x squared with 3 sine theta. But I still have this x squared. So now I have to replace the x squared. When you have to replace an x or a dx or anything like that, look at the other sides of your triangle that don't have the complicated root in them. So we're going to look at the x and the 3, right? So let's see. X equals equals, well, what function should I use?
Cosine.
Cosine, right? Cosine theta equals x over 3, so x equals 3 cosine theta. So now I've got x, and I can go ahead and find dx as well. So I'm going to find dx based on this. So dx is equal to negative 3 sine theta d theta. Are you with me? All right, so let's start replacing. So I have from my original integral, now I have the integral of, so my dx is negative 3 sine theta, I'm going to have a d theta over here. My x squared, what does x squared equal?
9 cosine
9
squared
cosine
theta.
squared. And then my root 9 minus x squared equals 3 sine theta. Once you've replaced all of your x's in terms of thetas, then it's just a matter of canceling and evaluating the integral. But there's, actually, it's not just a matter, there's more after that, but that's the next step. So, okay, so we can cancel a sign, and we can cancel a 3. So what we have now, I'm going to move this down. Okay, so let's just rewrite what we have. This now equals the integral of negative 1 over 9 cosine squared theta d theta. So how could we rewrite this in a way that we could evaluate?
Negative 1/9 the integral of secant squared theta.
Secant squared, right? So if we rewrite 1 over cosine squared as secant squared, so we get negative 1/9 secant squared theta d theta. Now we can do the antiderivative, right? We know the antiderivative of secant squared, what is it?
Tangent.
It is tangent, yes. So we end up with negative 1/9 tan theta plus c. But we're not done. Because the problem was presented in terms of x, so the answer has to be in terms of x. Which means we have to replace the theta back with what it is. So we go back to our original problem and we say, oh, all right, well, let's look at this one. If x is 3 cosine theta, that means if I divide by 3, so I get x over 3 equals cosine theta. So theta is the arc cosine of x over 3. Taking the arc cosine on both sides. Okay. So now I go back down and I replace theta with arc cosine of x over 3. But we're not done. Because, yes?
Oh, well, I was gonna say, couldn't you also do like sine theta over cosine theta?
Yeah, you could, which we're getting.
You'd get the same answer.
Yes.
Also, why couldn't you just like look at the original picture and just change the tangent of theta to like the square root of 9 minus x squared over x?
That's what it needs to do. You know, I'm thinking back to my first method when we had to do this at the end because we had never drawn a triangle. We did our triangle at the end. We already have a triangle. You're absolutely right. So, we have our triangle. See, this is why this is new. So, tan theta. Look at our triangle. What is the tangent of theta? It's just opposite over height or over adjacent. So, it's root 9 minus x squared over x. This is so much easier. Oh. Equals negative 1/9 times square root 9 minus x squared over x plus c. I love it. Thank you. Yeah, Isn't that nice? Doesn't that work slick?
Can't you
That's
just
real
combine
nice.
them together?
I say we just don't even
Oh, so
learn
you
the
like
other
with the 9 on the bottom?
Yeah, I know.
Like,
Sure,
let's
sure.
not even try to learn the other method. This one
Yeah,
is
I
just
kind of
great.
agree.
Yeah.
The more I think about it, this really is the best way.
Yeah.
Yeah, this is beautiful.
It is.
Okay, so let's give one a try, let's see if you can do it. Now, I'm just gonna give you a little hint. When you have a coefficient on the x, rather than doing a u sub for it, personally what I like to do is I like to pull that coefficient out before starting. And rewriting it like that. Alright, so try to draw a triangle. Remember now, you want the square root of x squared plus 4. So think about where the x and the 2 have to go in order to get a side that equals root x squared plus 4. Which side did the root x squared plus 4 end up on? Hypotenuse. Feel free to talk. You don't have to be quiet. Just because the camera's rolling, you can still discuss with each other. Oh, weird sounding clock.
Yeah.
Oh, I know. I know. It's gonna take time to keep going without anybody. And always make me nervous. Always. It sounded like something like.
Oh, no.
I was the class next to us.
But then you still have to replace it.
Oh, I could!
Sign.
Oh, no, I just. Because it's opposite.
Your answer or method might be different from mine depending on which side you put the x on and which side you put the 2 on. But it's okay. It'll all, in the end, we'll all be the same. So, so it'll all be good.
Yeah, but then.
Remember, whenever you're choosing functions,
Because it's one
always
square root.
choose a function with the thing you need, either the root or the x and the number. Never do the x and the root together, because then if you have to take the derivative, you're doing quotient rule, and all kinds of messy stuff happens, and it's just a pain, right? So go with the function and the number. Did you guys use cosecant? Just do 2 over sine, which is, alright.
What's the next?
Oh, yeah.
Did you get 1/2 cotangent? 1/2 cotangent theta?
Alright.
1/2 cotangent. Did you get, it's not, I'm gonna be 2. Well, no, because if you think about it, tan is equal to 2 over x. That means 1 over x is equal to, oh, yeah, you're 2 cotangent. 2 cotangent. Is it negative cosecant squared?
One of the most important things, the one thing that I saw a lot during 3rd period was people forgetting to replace the dx, right? So make sure you remember that you've got to replace everything in here, the x, the root, and the dx all have to be accounted for, right? Alright, so cosecant, so hypotenuse, and cosecant.
What's the integral of cotangent theta cosecant?
Yes, Joe?
Is it cotangent theta?
I did it, I drew my triangle differently, I switched the 2 and the x,
What's
Yeah.
the integral of cotangent?
and it was a lot easier than doing it.
Oh,
I didn't have
to
to
do all the
deal with- I
cosecants?
just- Yeah, I just had like secant, tangent.
Yeah,
It
you
was a lot less
record again,
complicated.
start over and do an easier one.
No, I thought that was pretty good.
Yeah, I thought this was
Thought this was fine?
No, I'm still on
Okay,
that.
just because you have secants instead of cosecants. So, yeah, if we put the x on the other side, it would be easier, because then you'd have secants and tangents instead of cosecants and cotangents. Okay, which is the same thing as what we had. Where's your dx go? Wait, but
Sure,
where's your
what is
dx?
sine theta? It's triangle. 2 over,
I'll get this one.
Yeah. And then this is your.
is equal to negative root. Is it the theta? Negative root square root x squared plus 4 over root 3 plus 6.
Okay, so you have sine.
Yeah, I always
So, negative, so negative.
Yeah. It's the same as sine, 2 sine
I just
times.
got negative square root.
Oh, okay, good, good. All right, let's try another one. As I get more comfortable with this method, I will probably
Wait, did you
learn better ways to make sure we label the triangles so that it becomes easy.
Sine theta
Yeah.
equals 2 over that.
Yeah.
One over that. So I multiplied that thing I had. Because I took out the 4.
That from here.
Oh, yeah, okay, yeah. I see.
So,
Yep.
what you might want to do is just write out some, like up at the top before you start doing this, write out some just standard trig values, like say, alright, so sine
Does that mean I have an eraser? Yeah.
And then,
Let's go.
cosine is still like tan, is 2 of x, right? And then you can just solve them.
Don't wanna waste paper, okay?
I need an x,
Cool, there's nothing wrong with wasting paper.
a dx, and I need a root x equals 4. So x
Don't want to,
root
like,
x equals 4.
have to go get another notebook, so I can like take paper.
Oh, okay, that's great.
Which I call 2 cotangent. And then
I thought for a
once
moment
you
that you were
get your
gonna be,
x,
like you were becoming.
then you find x is not just differential, and then you find
What are they good for?
Which side do you want me to put the 4 on, just so?
The bottom.
The bottom, you want the 4 on the bottom, you got it.
Do this one makes sense.
No, because, inverse, what you're thinking of, inverse arcsine and arccosine, it has to be number squared minus x squared minus x minus number squared. This would actually be arcsecant, but it only for arcsecant you have to have x in front of the root.
No, dude, that's not.
So it's not, it ends up being.
No, but you have to write it.
You have to solve for x. There is no x, but you have to solve for it to get dx.
What?
Oh.
Yeah, 5 minutes.
It's okay, Amanda, you can do it.
I know I can do it, it's just, I don't want to.
Yeah, I see your point.
Yes.
Yeah, I don't know, this is it.
You're good.
Brad, what do you?
Cosine theta is equal to 4 over x.
Okay, good.
So
Oh, yeah. Oh, and you end up with theta. Wow, Cole, you're so edgy.
did you get 4 secant theta for x?
Oh, that's right. Yeah, that's right. Right, yeah.
Beautiful. And then, so you just have to find the secant of theta.
So then dx is 4 secant theta tan theta
Oh,
d
you know,
theta.
when you flip this, you just drop the 2.
Yeah.
So yeah, so but then the 4 tangent cancel out.
Okay.
Well, Vigisha, did you get 4 secant theta tangent theta d theta for x?
Yeah, then they all cancel out.
There are 2 different, both. Guys, just so you know, there is more than one antiderivative for many given functions. So there are, for a lot of integrals, there can be more than one answer. There might be more than one type of function you can differentiate to end up with what you have. So depending on your triangle, you might end up with a different answer, but if you differentiate, will still be the same. So if your answer is similar to the answer, try taking the derivative and seeing if it works. And if it works, then you're good.
What's the integral of secant theta?
The integral of secant, natural log secant plus tangent.
Okay.
Natural log absolute value of secant plus tangent.
And is it positive?
Yes.
Cosine 4 over x.
Natural log of secant expressed in tangent calculate both and the
Do you that, Trace?
What?
Do this.
Hold up.
I have a formula. Want to petition the college board to make.
I got
It was
ln
a formula sheet.
absolute value x over 4 plus square root of x squared minus 16 all over 4
Plus C.
plus c. Yeah.
I talked to Chris about the food thing and Lauren was weird. This is I guess her answer. It wasn't Lauren. I get her answer was like.
You look better now.
I
It's
get
like,
her answer was what she wanted was like I don't care.
Alright, so I've heard at least 4 or 5 students say, what's integral secant?
The natural log.
So what's integral secant?
The natural secant.
Absolute value.
Still gotta memorize it.
did you use it on the
Okay,
test?
so, okay, so we need the secant of theta and the tangent of theta. The secant of theta is x over 4, and the tangent of theta would be root x squared minus 16 over 4, right? So you end up with ln absolute value x over 4 plus square root of x squared minus 16. Is that right?
Yeah.
Okay. The College Board would never leave an answer like this. And if this, and I guarantee this would be a multiple choice question, not a free response. So in the multiple choice, here's what they would do, just so you know when you are looking for your answer and you don't see it there and you're starting to freak out. Think to yourself, what would the College Board do? The College Board would factor a 1/4 out.
The board is evil.
Trace on camera.
Right? And then we know that the natural log of something times something, this is equal to the natural log of 1/4 plus the natural log of this, right? And of course, ln of 1/4 is a constant, so that gets absorbed into our C. So your actual answer that you would see on your test would be this one. That's what you would see on your test.
When you saw next to it.
Wait, where's the whole?
So anyway, so just know, they will never leave a constant plus C, right? It will always, all constants that are added or subtracted get absorbed into the C.
Where'd the one?
So technically, what I've written is wrong, right? These should all be like C sub 1, and this should be a C sub 2. They'll just have plus C on them. Yes?
So if there was a free response question that would we get points off for leaving
No,
comments?
no, no, free response is fine. You do whatever you want on free response. It's just multiple choice that you need to look for what they're doing. All right, good, let's try
My
another.
name is Arno Tsuyomoshi.
No, because they're equivalent. You can't have 2 correct answers. Yeah. There can't be 2 correct answers. In a multiple choice problem, they can't have 2 correct answers. They can only have 1. But what they might do, just to throw you off, is maybe like take one of these 4s out, right? And leave one in so that you're like, oh, well, mine's closest to that. I'm going to pick that one, right? Yeah. So,
But if you don't have all the math right,
Miss Price, for the AP Calc test, can you bring a coin with you?
so you can flip it
Yep.
and make the call. Yeah. I doubt they want you doing coin flipping during the test.
Well, technically, we'll be electing on the coin. Technically.
Cold number.
All right.
Just been checked.
Okay. Before you start this one, remember that the technique we're doing only works when you have roots, square roots. So how can we write this so there's a root in a root in it. Wait, is it Soro?
Yeah.
Soro, yes.
See, do the square root of x squared plus 3 cubed.
Square root of x squared plus 3, okay. I'm with ya.
Did I just say that?
Just say times x squared plus 3.
Couldn't you like
okay.
cube the thing though?
Yeah. Well, yeah, but.
Oh, okay. I'll just times it again by like
You can just
Wait,
add
x
another
squared plus
integral of x squared, 1 over x squared plus 3, right?
Or you just.
x squared plus 3 times. I got you.
Am I multiplying?
We're
You
restate
can't
that.
add multiplication, Shreyas.
Alright, I'm just writing cube, right? But you could
That's what I
put what I understand what you guys are saying, you could rewrite this as the quantity x squared plus 3 times the square root of x squared plus 3, right? Which is fine. Or you can do it as just root x squared plus 3 cubed, and then you don't even have any outside x's to deal with, right? So I'm going to give this one a try. See how this goes. Draw a triangle, label your triangle. Is that a yo-yo? That's like a major yo-yo.
She was just breathing with her mouth, that's all.
Yeah, I don't wanna go home. This is fun.
Say no one ever.
One time I told you're a savage.
It's gonna be the best lesson.
Everything is going on camera.
Yeah, how about carrying it over early, maybe it's so packed up.
Shreyas, what'd you say about
Your class?
Shreyas, what'd you say about that?
I love the college.
Hey, since the camera's recording this, like whoever's watching this video, should let's do the college board.
Nice.
I like that. Right.
Nice.
So then,
Got him.
And Dale, yeah.
if you want to do the college board with me, just post in the comments your social security number. I can sign it away.
You hit.
Hannah, this is one of those playgrounds.
Ooh!
Who says I don't do that?
Who says that? I didn't say that. I'm in your actions. You know, you didn't hit. You didn't. You missed.
Sorry, Brian. Now,
Not a little more.
solve something.
No.
X squared plus 3. What?
No, I'm just trying.
Oh, yeah, absolutely.
Oh. Just gonna look out the window. Right out, like Riley. Whatever. Sorrel,
So then solve.
clean your mouth up, please.
Alright, go.
Brian, why can we sit? It's okay.
You doubt if there's people walking around.
Hold on, Mark.
Hey, Corey,
What'd you even say?
because I ate because I spilled my barbecue sauce.
No, Shreyas, stop Shreyas. Oh, Shreyas.
I don't eat in the kitchen. I eat my own.
Did you actually tell all of these?
No.
Very bad. I haven't had any class.
I use your hand. Look at
He said,
that.
no, he said Arnold's doing it first.
Unless you're a bullet.
Alright,
Alright,
are we finding in general, and I honestly don't know, because I haven't done enough of this to know, so you tell me, is it easier to have the number on the bottom or the X on the bottom?
It depends.
It depends, varies.
Yeah.
The number or the X?
No, I was trying to think, because I just went down for a second.
Number on the
Yeah,
Number on the bottom? Okay, alright, what number would need to be on the bottom?
Root 3.
Root 3. Good, so then X is over here, square root of X squared plus 3, right? So we have root X squared plus 3. Well, let's see, if we use secant theta is root X squared plus 3 over root 3, so this would be root 3 secant theta. Now, the trap is forgetting about the dx. right? Don't forget the dx. Because if you just write this as the integral of 1 over root 3 secant theta cubed, it's a doable integral. It's not as much of a fun integral as what you end up if you remember your dx, right? And it's also wrong. So make sure that you replace the dx, right? So we need to take another function that will be just in terms of x. So I would use tangent, right? Tan theta is x over root 3, so x equals root 3 tan theta. So my dx is root 3 secant squared theta d theta. And now I've got a nice full integral because I can replace my dx with a root 3 secant squared theta d theta. Right there. All right, this is cubed. Everyone in my first and third period, because we did all get to the same point, just using the other method, did all the stuff with the secants fine, but messed up the numbers. So be careful that you cube not just the secant, but also the root 3. So you have root 3 over root 3 cubed, and if you cancel root 3 on the bottom, you end up with 1 over root 3 squared, which is just a third, right? So you end up with 1/3 integral secant squared over secant cubed, which is 1 over secant or cosine. I'll write the 1 over secant just so people see the step. And then you end up with 1/3 integral cosine. What's the antiderivative of cosine?
Fine.
Is it positive or negative?
Positive.
It is positive.
Stop trying to trick us.
Alright, so we have 1/3 integral sine theta, but sine theta is x over square root of x squared plus 3. So we replace the sine theta 1/3 times x over root x squared plus 3.
You're my boy, Cole.
Whoa.
Is that alright. How are you guys over here? Good. Sure.
Hold on, Cole, I don't know why you're here. I'm just saying, my son.
Wait, this price?
Cole, why are you treating your father this way?
Oh wait, this wasn't
That's what I thought. You know, you should show your family a little more respect.
I don't think these is
I can't imagine that way. This price?
Think about these things today, it's hypothesis like Good. Any other questions before we run? Yes.
If you use cosecant instead of secant,
Yeah.
your answer would be negative.
Yes.
So is that fine?
And that's okay.
Okay.
That's okay. Because what will happen is if you take the derivative, you'll be okay.
Alright.
So what do you do on multiple choice? Do they pick one or the
They
other?
can't have 2 correct answers for any single problem. So you would have to pick
Okay.
one that's right. Yeah.
Are you sure?
Okay, so it's time to do a little BC review. Oh, that rhymes.
BC review?
Right?
I don't get how that rhymes.
It's time to do some BC review. Do and review.
Yeah, Brian. You can't take much well.
Okay, so this is 2001 number 5, which to me feels fairly recent, but had it pointed out to me, not by a student, but by a teacher, that 2001 was a really long time ago. So, anyway, it's to me not, but that's okay. One of our newer teachers. So, let f be the function satisfying f prime is negative 3x times f of x. for all real numbers x with f of 1 equals 4, and the limit as x approaches infinity of f of x equals 0. Part A is something you haven't learned yet. We will do this in about 2 weeks, but if you tried it, and it doesn't take that long, if you try and just go, well, I bet it's this, and I'll just try that, and let's just see how it goes, you'd probably be right. Every single person that's tried it today got it right. So, part A. So just give it a try, right? See how it goes. But either way, if you don't get it, that's okay. Part B, though, that you need to do, right? Let's review some Euler's method. It's been a whole day. So, sometimes you forget. So we're going to start Euler's method starting at 1 with a step size of 0.5 to approximate f of 2. So you're going to do 2 iterations of Euler. And then the final one, you're solving the differential equation. dy dx equals negative 3xy with the initial condition f of 1 equals 4. So take a few minutes, give this a shot. Feel free to work together, especially on part A. See what you come up with. The key for A is
Wait, do you
that
integrate?
is an but it's the integral of f prime. Oh my god. Well, no, you gotta actually you got it. Good. Can you not
Well, in all honesty, Miss Price, I was also in stats here last year.
Nah. It's like,
I don't think I
I'm
what
not
would you
gonna
do
let
with
you
an
do
integral?
You want to sit on the bench, Lord. I would do that. Oh.
Why not?
Well, like, I know the steps to it, but like, how would you integrate negative 3x?
Alright, how are you guys doing? Yeah, you can't do that. Instead, look at the very first line. F prime is negative 3x f of x. So could you replace the integrand? They're trying to find the integral.
Wait, so it's just the integral of f prime.
So, yeah.
Okay, so it's integral of of f times x, which is f of x.
I'm sorry, I still understood it. Starting at.
No, wait, no. Integral of f.
Then how do you get?
Oh yeah, because so it's just f of x, and f of x is equal to.
Does it matter when it's absolute?
Claire's got it.
So f of x from 1 to
It's not plus C,
1 to
it's
infinity.
Just, you can go ahead.
-4.
Oh, I got you. I got it. I got it. No, because okay, so you do f of x of 1 to infinity, and when you plug infinity into f of x,
You mean like
you
solve
have
the
it's
differential
0
equation
because
with your part C?
as f of x goes towards infinity 0, and that's
Yeah.
like 0 minus plug 1 in, you get 4.
See what happens.
Wait, but what do you do with the C and the
The
equation?
integral of f times x is just f.
You get B at?
So f.
What do you do with?
So it's from
Oh, you have to find the.
integral of 0 from 1 to 0.
2.5.
No, integral of f of x from 1 to infinity. And then, oh, this right here, since negative 3 f of x is
You have to
equal
solve
to
for
f prime
C.
x, negative 3 f of x,
Cool.
f prime of x. So I substitute it, and then when you take the integral of that, you get that.
Did you get C?
Plug
I'm
in
not gonna take
infinity,
the problem
you
away,
get
I'm just gonna
Negative 3x squared over 2.
But I'll still have the.
You said we did that.
Hello?
Okay, wait, 0. Oh,
So this is the same problem. There's the answer to part A, just in case you're curious. In my last, the inner comments were all two-way, so if they needed to talk to someone in the room, they just hit your room and said, this is Bryce, and then you'd yep, and then you would have a talk. No, there were no phones. It was just intercom.
That's it. How do we do that? It's like high tech.
right?
You know, like, he's supposed to be high tech. What? Wait, what did you do, Shreyas?
Okay, so when you plug your.
God dang it, Shreyas. Brandon, how's it going? Good.
Brian, come step for us.
Why are you dropping so many F-bombs in the camera? The camera can't handle it.
Brian, stop saying.
I'm not saying anything.
Hey, don't do that. Don't do that.
I'm just gonna give my L.
Here's an L for you, Shreyas.
Brian just handed Shreyas an L. Dang.
Brought up really like the installation.
Wait, X equals 1.
Brought up really is the definition.
Oh, because you know F equals 1 is 4.
Hey,
Are there?
Cole, why do you want the Kleenexes?
Now remember guys, they do the formula method, but remember they accept either way. So you can do the not tangent lines, right? Right? Or do the formula for part B.
Or equivalent table.
Yes.
We have to actually sketch a table.
No, it's fine. They don't have a table.
Hey Claire, did you say you got 2.5? I mean 6 when they did 6.5 or something?
We should film more often.
I think we film every day. You know, one of these days you need to get just need to get a little screenshot.
I am, just so you know, I'm going to post both videos online tonight so that you can watch either method. If you're uncomfortable making triangles, you can watch the other way.
Dude, I have a whole line.
That's sound up, guys.
Good.
Yeah, honestly. That sound up when he was talking about the college board.
Why do I have to get out there? I registered for this class. What did you do?
And actually tomorrow we have a second day on trig substitution, so.
We are not that long.
And even with all that space, your handwriting still is bad.
Alright, any questions?
It's a masterpiece.
I feel like most of you look okay.
This is a masterpiece.
Yes, I got
This is a skill.
C right too.
What field?
Maybe just right.
Exactly.
So like on this one right here, how would you solve the next one then?
Oh,
Because you don't know
so
it.
you've got your x and your y. Treat f of x like y. So it's your slope, f prime, is -3 times x times y. Think of it
Oh,
like that.
okay.
Yep.
Okay.